I am Trixie Nicole Nobong, a grade 12 student of Immaculata High School. And in this video, we will be discussing about heat and temperature, as well as their differences and how they are connected. Heat and temperature are interconnected, but contrary to popular belief, because they do not mean the same thing. Knowing the distinction between heat and temperature can lead to a clearer understanding of the world around us. In this video, we will define heat and temperature and reach an understanding of how they are related but not identical. The reason why the concept of heat and temperature might be mixed up is because of how closely they are related in real life. If you add heat to something, its temperature goes up, and if you reduce the temperature, you are taking the heat away. Let's see at what they actually represent. Heat is the total energy of the motion of the molecules of a substance, whereas temperature refers to the measure of the average energy of the motions of the molecules in the substance. The heat is dependent on factors like the speed of the particle, the size of the particle, and the number of particles, and etc. The SI unit, or the Standard International Unit of Heat, is Joule. The temperature, on the other hand, is independent of these factors. For example, let's compare a tub of water with a cup of water. The water in the tub and the cup can be at the same temperature, but by the virtue of the number of particles in the tub, the water in the tub has more thermal energy in it, and thereby more heat, even though they have the same temperature. Temperature is a number that relates to the energy possessed by the molecules of a substance, which directly relates to the kinetic energy possessed by the particles of the substance. The SI unit, or the Standard International Unit of Temperature, is Kelvin. As I said earlier, the temperature is directly related to the kinetic energy of the molecules. Therefore, if you double the temperature of a substance, you double the average of kinetic energy possessed by those molecules. Let's take a closer look at heat and temperature now. When you add heat to a substance, you are giving it energy. There are two things that can happen when you heat a substance. Number one, the substance undergoes a rise in temperature now, corresponding to the increase in the kinetic energy of the molecules. The heat gives the molecules extra energy to move around with more speed. And this increase in speed implies an increase in temperature. The molecules now travel faster than before the heat was applied. Number two, the substance can also undergo a change in phase or state. One thing we should remember is that the energy added to change the state of a substance does not result in an increased temperature. We can calculate the heat released or absorbed using the specific heat capacity, the mass of the substance, and the change in temperature. See the equation. That is Q equals m times C times T, which is the temperature. In conclusion, in thermodynamics, heat and temperature are closely related concepts, but with precise definitions.